Hello again, guys. This is Tim Cain on code refactoring, something we all have to do and all hate to do, but guess what? Tech debt cannot be avoided. It really can't. You can try to make the perfect game your first time, you're not going to do it. And you're probably not going to do it your second time either. What does Tim have to say about code refactoring?
Hi, everyone. It's me, Tim.
Hi, Tim.
And today I want to talk about code refactoring. B892 asked, in the games industry, how do you handle code refactors? Is there time for it? How do you approach it? Are there dedicated time periods dedicated to refactoring? Or is it done in small bits throughout development?
You pretend that you don't have to do it up until you absolutely have to do it, and then you forget to assign the proper amount of time to do it, and your coding team comes back and says, well, it's going to take us about a million years to refactor this thing, and production says, well, we have to do it in 2 days. So how do you avoid it? I mean, here's the thing. How do you avoid any sort of unknowns in game dev? You prototype. You spike is, I guess, the proper Scrum word, right? You determine what you need to do to properly resolve the issue, taking into account as many things in the future that you can think about. But inevitably, you will never be 100% perfect. You will always create debt. You may just not see that debt until it comes time to pay it back, right? So I think the best way to deal with it is to have really, really solid pre-production, to prototype well, to communicate, to plan effectively and efficiently, so that when you do create something, you can identify, okay, this, we've kind of coded ourselves into a corner here, but we are nearly sure that we will never have to touch this again. That doesn't mean that you won't, but, if you're pretty sure, I guess that's better than not being sure at all. Or you make it in a way so that it is modular and can be upgraded and easily, put additional bits of code into it. That's the ideal, but that does take more time than sometimes coding yourself into a corner, right? And when you're making a game, you do need to efficiently determine, okay, this code can and should be modular and very upgradable. This code can be messy and one time, because we're not going to make another game with this sort of functionality. We're not going to use this or update this in the future. This works, and we don't have to look at it or touch it ever again. It's a balance, and it's about making it efficient so that you spend the least amount of time developing as possible. And then your future games, sequels, games of similar genre, whatever, can use those core systems, right? Maybe you make RPG games, and every RPG game you make has dialogue. So it is more efficient in the long run to make a modular, well-coded, well-structured, well-organized, easy to work with dialogue system that you can use in game 1, 2, 3, 4, etc., than it is to make one-use dialogue system that is so broken and horrible that you have to remake a new dialogue system for the second game, right? If it takes 3 months here, 3 months here, versus spending 4.5 months to make it better and usable in the second game, yes, you are increasing the length of development for the first game, but you're trimming the length of development for the second game. That's unfortunately why some studios struggle to get off the ground, is because they're often on such limited shoestring budgets and time constraints that they need to do things as fast as possible. But by doing things as fast as possible, they're also shooting themselves in the foot for the second, third, fourth, fifth game, and they end up in this constant chase to keep the lights on and keep people paid, and they never really develop those systems that they can bring from game 1 to game 2 to game 3. Kingdom Come Deliverance is a good example. If it's true that the game only costs 40 to 50 million dollars to make the sequel of, that's crazy. That is crazy cheap for a AAA game of that size and that scope. And the reason they did that is because they spent, in my opinion, a good amount of time creating these good systems in the first game, that really the second game was just content. They already had the dialogue, they had the combat, they just had to make some iterations on it. They had the inventory system, the crime system. They just iterated upon these things and added a lot more content to the game, and that's where most of the money went to, not making things from scratch like they had to do the first time. I'm sorry, Tim, I'm getting off trail here. Please continue.
B, that's a really good question. I thought I did something, but when I looked, all I did is kind of mention code refactoring when I did a video on optimization, which I'll link below. But code refactoring is done for more than just optimization reasons, so let me get into it. First of all, what is code refactoring? That's whenever you restructure existing code, so code that's already written and works, to make it better. And I'll talk about what
Yeah, you have to
better
define what
is.
better
But
means,
usually
right?
it means you're rewriting it because you want it to be cleaner and faster.
Cleaner, faster, or just have more options, right? If you a good example with today was the info panels where I'm shoving this new icon onto. I kind of wrote myself into corners here, and I would have to refactor these in order to make them work properly. And we're going to have to refactor these when it comes to our alchemy rework. I kind of knew that when I was making it, and it's just I'm going to have to refactor it because right now it would take me more time to make it work with the system that we have than it would be to just delete the code and remake it from scratch, realistically. And that's sometimes what it comes down to. It takes you more time to put a bandage on top of the million other bandages than it would be just to write it properly from scratch.
It's usually bug free before you start, but I've had some code refactors because there was a pernicious bug that I literally could not find, and I
Yep.
refactored the code and it disappeared.
Mm-hmm.
So let's talk about why you would want to refactor code. There are three big reasons you want to do this: efficiency, maintainability, and reusability. And these are all different. They're a little related. They have a little bit of overlap, but they're three different reasons you want a code refactor. So let's walk through them, and I'll give some examples. The first reason you want to do it is efficiency. Maybe you have code and you want it to be faster or use less memory.
Yeah, like it does a lot of like loop iterations or something, and you're like, well, we wouldn't have to do this if we structured the data better. So let's structure the data better, refactor the code, ignore those loops that we have to do, and save the player some, especially when it comes to anything that runs on like every frame or is run on a like constant tick and it all happens in one thread, one of the game threads. You want to make sure that that's optimized to avoid stuttering, right? Because if otherwise you will have stuttering if too much is being done in one game thread, and you maybe either have to accept the stutter or increase the minimum recommended hardware for the player so that they're using a CPU that will not have that stuttering issue.
That's primarily the stated reason people say they want to refactor code. Usually programmers are like, "Hey, I could do this better if I had a second time." Usually this is done by you see how your code is really being used. By the time you go to code refactor, other systems are in place.
Yeah,
And
by the way, that's an important aspect where you might do 100, you might do 1,000 loops. That's with some pretty complex stuff in between. But if that's only ever happening in some menu where any sort of hang or stutter might be, a couple milliseconds, but those milliseconds aren't really that big in the scheme of using like an inventory, switching tabs. Is it really that high value to spend so much time and effort to refactor that code? As opposed to in the middle of combat having to do a whole bunch of checks where any sort of stuttering or latency can, really impact the player's experience with combat and the enjoyability. That might have a much higher value for the effort being put in than refactoring some inventory code or something.
they're using this particular piece of code. So you see, like, how's it used? How frequently is it
Mm-hmm.
used? How many objects use it? That kind of information should guide your refactor and your rewrite of the code. And I'll give you an example. Let's say that you have some piece of code that at some point it has an array that things get put into and occasionally resorts it. And you wrote it, it has a simple insert, it just throws it at the end, and then when the resort comes in, it just does like a quick sort of the entire thing.
Yeah.
But when you're actually looking at how it's used later, you notice that usually because the array is sorted and things are just being inserted at the end, quicksort is not the best thing to use here. There are other algorithms that work a lot better with an almost already sorted array. So right then you might think, well, I may need to change my sort algorithm. But then you think, well, wait a minute. If the array
Do
is
I?
already sorted, it would be easy to insert the new item at the correct spot
Mm-hmm.
because you do one linear pass, bam. However, this would depend on how frequently you're inserting and how fast that insertion needs to be. If that insertion needs to be near instant, it's easier just to throw it on the end and then sort when you don't have to worry about
Yeah,
time.
like some
We
asynchronous
used to do
thing.
things in several games I wrote where there were times.
Like for instance, if you pick up a new item, right? And you do want to have that sorted in the data backend. It's better not to sort that every time you pick up a new item. It's actually better to sort it every time you open up the inventory. Because otherwise, if you know that there's going to be a bit of a hang in the game, you'd rather it occur when the player is requesting that inventory to be opened, as opposed to, or even, yeah, put a sort button, right? So that you expect as a player that there might be a hang, rather than it being every time you pick up an item in the open world and it hangs for a little bit every time you pick up something because your inventory is getting bigger and bigger. No, I mean, yeah, that's a perfect example of that.
Where there were lots of CPU cycles available. So we would do things then. A perfect example of that was when certain UIs would come up,
Mm-hmm.
whether it was inventory or looking at your character build or even bringing up an options menu or the pause menu, the game would be paused. So suddenly a lot of systems which eat a lot of cycles like AI or even rendering,
Yep,
suddenly those aren't doing anything.
that's the
You
perfect
can
time to
use
do
those
it.
cycles to do other things. For one of our games, we use that to do garbage collection because Unity garbage collects when it thinks it's necessary, which can cause stuttering in your game. So the way we avoided that is we manually called garbage collect at times we knew a stutter would not be noticed. Because a stutter of 100 milliseconds is really noticeable in a 30 or 60 frames per second game,
Yep.
but is not noticeable at all when you bring up a pause menu and you're like, I wonder if I want to change an option, or I think I'm going to go make a sandwich. 100 millisecond pause to do a garbage collection, no one's going to notice.
Nope. So is garbage collection in Unity kind of shit? Because I've heard some other people mention that Unity garbage collection is horrible. Also, try to write better code. That too. Oh, not really. Oh, I wonder what they were doing then. I know Unreal's garbage collection is pretty good. And it also depends on what you're trying to actually shove to the garbage collector, right? I mean, everybody knows that Unreal RAM usage is pretty high. But you can always increase the amount of time that, like, yeah, I mean, in general, just doing asynchronous garbage collection is always good. Doing it in, like, the background of a pre-rendered cutscene or something. When you write zero allocation code, you barely feel it. Huh.
In terms of this array resorting, it may be that you're free to resort that array in one of these downtimes. So you make insert super fast, and then who cares how long the resort takes?
Yep.
Or it may be that both of them have to be as efficient as possible. So maybe you add it to the end and you use a better sort algorithm. Or maybe you do, when a new item comes into that array, you stick it in the right spot. So that
You could always shove it on a different thread too and just let it go in the background and then prioritize, doing that when the player requests it, right?
way you never have to do
There's some
sort.
different ways to do it.
It depends on how it's used. So without that information, without usability information, you, the programmer, cannot make that decision, which is one reason code refactors, I recommend pushing it off. Wait to see how your code is used. Just like optimization, doing too early of a code refactor is bad, and I'll talk about that.
Yeah, I know, I'm going to call out some friends here and they're not going to like it. But hey, Twitch Talk, there are some coders that I really, really like. They're great coders. They're a million times better than I will ever be. However, trying to make every single thing in your game modular is a waste of time. It's a huge waste of time. I get the desire to like make a coding language or a system of developing a game so modular that you can just put all the pieces together and it will work. It's a waste of time. I feel called out here. I mean, I think you just need to determine when you need to do it. You don't always need to do it. Again, I really love certain friends of mine that, they're, like I said, I can talk to them about a coding problem. They will solve it. No question about it. But I think that a lot of times modularity is a waste of time in game dev. I think that if you're a hobbyist and you don't have to worry about time, go for it, right? This is your time, nobody's pressuring you. But when you're in professional game dev, you do have that time constraint. You need to determine which systems actually need to be modular and what of them need to be expandable. If you know that you're only going to have two of an item in the game, don't spend so much time making a system that can read some infinite amount of items and handle it properly when this is never going to be the case for your game. Stop it. Stop wasting time. It will take you 3 weeks to do it one way or 3 days to do it another way. Choose the one that only costs 3 days. Save yourself a lot of time and money. A modular system which will benefit from it. Yeah, and that's how it should be. And you won't always know that. Sometimes you might make a modular system that you thought you would use more but didn't. But you also might make it in terms of like, okay, this is going to be moddable by players. So we might not use it very much. They might. So we are going to make it modular in that way.
The second reason you want to do code refactor is maintainability.
Mm-hmm.
If this is code that's generic enough that you intend to use it in other games you're writing, or you're doing like a live service game, or just a big enough game that you're gonna have to come back again and again
like DLC
to look
or
at this code to potentially add new features,
mm-hmm.
or to fix bugs that you didn't see when there was 100 playtesters, but you're seeing it now that there's 1 million people playing your game. You want that code to be very clean. It's called less spaghetti code, because you want a new programmer, because who knows if you're going to be the one doing it, or even you 6 months later know what's going on here.
Yes.
People always say, well, why are you even writing spaghetti code? Spaghetti code happens a lot in the game industry because changes happen to the design of the game. Either the design was flawed, but you didn't realize it till you implemented it, or
scary,
a better idea came along. Maybe you put it in front of a focus group and they're like, well, if this UI just worked this way, that would be easier. By the way,
yeah, I mean, I think that's one of the things that gamers who don't know anything about game dev often will confuse is that, oh, why didn't you just design the game properly from the start? Well, most games aren't designed properly from the start. I don't know any game that was designed so perfectly that they just implemented it according to the original design documentation and never had to make any changes. It's never the case, right? You can try to do that, but you're never going to be 100%. I think the most important thing is to make your high level design good so that you can change some of the low level, but the general idea of the system and how it functions in the game is going to remain the same. And that's what pre-production is for, right? If you spend a good amount of time, high level design is easy to make. It's easy to come up with a concept. What's really difficult about game development and game design is to take that high level concept and to make sure it works when you actually have to create the details, right? And to balance it all. And that's why I will often spend a lot of time thinking about high level, because I'm also like in other threads of my brain creating bits of the low level to see, okay, is there a hole here? Is there an issue with this? Oh, this at low level does not work with this piece of high level. So I need to refigure the high level of this. If you're already post vertical slice and changing the high level of your game, you probably fucked up. Simple as that. You can change low level. You can say, okay, well, this part of the feature, the fishing bait knowledge being unknown to the player is not very fun. So we just let the player get the knowledge right off the bat. This doesn't change the high level of fishing, that you need to use specific baits for certain fish. It just changes a piece of the low level that was not very enjoyable to the players. Never write spaghetti and leave it for future you. It won't be pretty. At the same time, I don't think that you will ever be able to not write spaghetti. It's like you will never be able to avoid code refactoring, because I don't think you can ever know 100% what your game is going to be. I mean, maybe if you spend 20 years figuring out what your game is going to be, I guess you can avoid it, but I don't know. Why did you write bugs, Mr. Programmer? Oh yeah, yeah, because I decided I'm gonna fix 3 bugs today and put one in there intentionally. That's why. I notice and figure out. Yeah, I think there was a good talk that I saw from a code architect at Digital Dragons. Um, it was very surface level, so I was able to obtain information from it, even as a non-coder. And it's really just like I said at the start of this, you will create tech debt. Everything you do in your game will create debt. You may just not have to pay it back until one day, 1 week, 1 month, 1 year. At some point, if you are going to continue the development of your game, the tech debt will have to be paid. It will. And a good code architect, good prototyping, good pre-production can all help to minimize the amount of debt because you will realize the wrong ways to do something and decide upon better ways to do something. Short spaghetti because spaghetti works as quick and dirty prototype. Play with it. If it works the way you like it, then you can go in and deep spaghettify. Yeah, exactly. And I think that's the proper kind of mentality to use with it.
I've seen and written some really bad spaghetti code in UI because you have to write it over and over and over again to try to accommodate how people are actually using it.
UI is hard.
When you rewrite it over and over.
That's why you don't waste time on UI art, because UI will constantly be redone and moved around a bit. And I promise you, if you make your elements in a way that isn't very modular in UI, which can happen, it just some elements are like that. Oh, because the players prefer the button over here. Well, now I have to fix the art of it. Why don't you just make the functionality and then make the art?
Again, frequently, even the most simple design change can result in a dramatically big change to your code.
Oh, yeah.
This leads to spaghetti code, where a method that is named one thing and was supposed to do one thing is now doing 3 things, or some method that was only supposed to be called once or twice is now being called every update. Just a method got longer and longer and longer and longer until finally it's like 10 or 20 pages of code, and you're finding where to make a change in it is a nightmare. An example of that would be one of the games I made that had fast travel. Time would pass during fast travel. If you went from here to here, when you arrived,
a lot of simulation to do.
Okay, 3 days went by. Advance time 3 days. Well, guess what? That would advance status effects that would tick. Many of them ticked every heartbeat, like every 2 seconds.
So you would die. You're poisoned or something.
If a status effect was a damage over time, that could kill the player. So it was weird that you walked all this distance, arrived in this town, and fell over dead when that dot should have killed you 2 minutes after you started out. So now you have to make fast travel constantly tick time really quickly as it goes along.
You could also prevent the player from fast traveling while they're dying of some DOT. I mean, if you want to make it a bit easier, and I think that's a bit more player friendly because you may forget that you're dying of like bleed, and you try to fast travel, and you're like, oh yeah, okay, I can't do that because I'm bleeding. Let me solve that first. There's some high-level things that you can try to do from the outset. If you need a new feature, make it in isolation, then have your game call the feature. Try to avoid going the other way where possible by not having the feature call into your game. There's some of that you can do where like that isolated prototype, but at the same time, I think that there are certain types of games and features that are so ingrained with each other that there's no way that you can decouple them. Or even if you could, it would take way more time than it would be worth. From a UI code system where it won't matter how you design it visual-wise, it will always work. You can replace elements or put them wherever. Yeah, that's a good way to do it. Yeah, and just worry about the art last. I mean, if you're not showing it to players, I think for most cases, UI art is more of just like a flavor thing rather than a usability problem. That's why most games work on it last.
And if one of those effects caused a pop-up UI, like something comes up and it's like, you're low on health, or, you still have poison. Do you want to take care of that?
Yep.
Can that happen during fast travel? Maybe your fast travel UI, once it's started, can't really handle a pop-up UI interrupting it. And you have to change it so it can. Those two changes, the continuous ticking and pop-up UIs, it's going to make your fast travel code look like a mess. And when you're done and you have time, you may want to go back and go, okay, now that I know that time has to tick continuously and pop-ups may occur, I want to rewrite some of this fast travel code. And then the final reason you want to refactor your code is reusability, which is separate from maintainability. Maintainability is you just keeping that code working correctly and being efficient and bug-free as the game is live or has DLC added to it and new features. Reusability is you may want to pick up that piece of code and use it in another game you're doing. You don't want to remake the wheel every single time you make a game.
And it saves a hell of a lot of time if you can do this properly. And if you manage to fund your game and take the time necessary to do this, your subsequent games, if you work in the same genre, will become cheaper and cheaper and cheaper. That's the golden dream for most game companies, is that they can just, pull from some libraries, pull from some past experience, reuse certain features, and they can kind of, get 50 to 60% of a game already made before they have even spent any money on it, right? So that's the golden dream, and I think that, like we mentioned, Kingdom Come Deliverance 2 is a great example of that. That game only cost $40 to $50 million to make, which is still not a small amount, but for what that game is, that is a very, very small amount compared to most AAA games now. It's a sequel. You can kind of get away with that, right? Because nobody expects a sequel to be significantly different from the prior version. That's one of the benefits. But now if they ever made a game, let's say, I don't know, this same idea, but it's in a sci-fi world, right? That same kind of an ImSim, they could probably reuse some of the things that they've made in Kingdom Come Deliverance in that new game, and they've saved money and time by doing so. There's going to be exceptions, then you might be relying on events or DI to limit the coupling. Yeah. I think that, a good game is you code the rules and you script the exceptions, right? So if you have, if this function handles 99% of what it should do, and then you just code a branch in to handle the other 1%, it's good enough. Good enough. You just need to make sure that you aren't, there's another 1% exception, and another one, and now branch, or some case switch, which, is not too terrible depending on the number of it, but you want to be careful not to do too much of that. You believe in making a template of systems that can be reused. It's what I'm doing now. That's where modularity can come in handy. Make your first game, and for the second one, if it's the same genre, they can use the same template base and add minor things. Yeah. And some of that is worth the time, and some of it is not worth the time. It just depends on what it is.
Refactored code can often be made more reusable by isolating the specific parts. So now you can have a module or sometimes even a library, and you're like, this is used for this thing, which is very generic. I can use it in a lot of games. So I want to make that code very efficient for reusability.
Like a interaction
example
system.
Of this that I've talked about on this channel is when I took all of the DOS specific calls in Fallout and isolated it to a library called GNOL, because we knew we were changing it to Windows. We were also going to make it run on Windows. So that let us rewrite all those DOS calls to be Windows calls just in the library. The game
and just
itself
plug
had
them in,
no idea this change was happening. If it needed a window to pop up or it needed input from a mouse or keyboard, it just called into GNOL. How GNOL got that information or displayed things was a mystery to anyone who was writing in the Fallout game code.
Yeah, it's just like, open window. You may have to do something different for Linux, for Mac, for other systems like that, and having just that call, the game can just either switch based on, or that library can switch based on platform, things like that, right? So you don't need to rewrite any of the game code. Smart way to do it.
This was so effective, by the way, that one of the first things I did after leaving Interplay was write a brand new library called TIG. GNOL stood for GNOL's Not Windows. TIG stands for TIG Isn't GNOL. TIG had even more advanced Windows features, things that I didn't do because I needed to support DOS. I stopped supporting DOS with TIG and got even more advanced Windows features in it. This GNOL and TIG made it very easy to port the game. When we wanted a Mac version, you only had to change calls in those libraries. If you wanted to update something, like if a new version of DirectX came out, the only thing that used it was inside those libraries. So nothing in the game itself had to change. There's an entire video on GNOL and TIG, and I'll link it below. So now let me get into what the pros and the cons are
You'll
For
know too, especially, the nice thing about that is that generally speaking, if you know that the game code itself is unchanged, you just need to test whether or not that switch in the library is okay, right? If there's some different call for DirectX 9 versus DirectX 11 or DirectX 12, you just need to know, okay, is this functioning? You don't need to do so much regressive testing because, okay, now we changed the game code, therefore check this too, check this too, check this too. You know that you've just modified that thing that was in isolation.
for code refactoring. The pros I shouldn't have to go over. Done right, it's everything I just said. You'll have faster code, better code, cleaner code. However, that done right phrase is doing a lot of heavy lifting here. So let's break down what I think to be a lot of cons of code refactoring. First of all, it's frequently done too early.
Yep.
Programmers will love to say, yeah, I just wrote something, I want to refactor it. Really? You don't even know how it's going to be used.
Yep.
You don't even know if it really has any bugs in it or if it's too slow for the application. But like, yeah, but I can make it faster.
Yeah, and it's like I said, there's a lot of cases where it's a waste of time. I mean, that's why in prototype, I'm like, it's messy, but you know what? I know I'm not going to touch this, or I'm very confident I won't touch this until vertical slice. That's when we'll refactor it. Like, not now. All I need to do now is determine, do we want it? Does it function? Is this exactly how it's going to, work in the game, right? Is this data moving properly? Okay, the data's moving properly. It works. It functions. Who cares how it looks or how it performs? It doesn't matter in this case. And then the programmers can take a look. Okay, we need this data in, this data out. You handle it with a loop. Okay, I see why. I see. Okay, I see it. We can refactor it in a way. I get how it's going to go, and that refactor ideally should take a lot less time because I've already solved a lot of the bigger questions, right? And then they can make it more optimized. They can make it more modular, more expandable, more scalable. That's exactly why you do that pre-production like that.
But what if you don't need to? If
Yep.
you have something that's called once every 10 minutes, who cares? So I've seen early refactoring frequently just the same way I see early optimization, and look at that in the optimization bit. My recommendation here is wait to see if you even need to refactor it. Is your code too slow? Is it too messy? It may not be. And just having a better idea of how to do it is not a good reason to refactor.
It's true.
And then doing it too frequently. Again, I've worked with programmers who they want to refactor when they get to the end of the task. They're like, okay, I've written everything and it's working. I want to refactor now. They want to refactor if they have I have a better idea of how to do this. Let's do it. Or
You should have had that idea during a planning session, right? You should have had a planning session with your scrum master, with your lead, maybe both, or with the rest of your team to determine the best course of going forward. That should have been done initially. Now, I don't want to have you spend 2 times the amount of time or 1.5 times the amount of time doing the task just to save some minute amount of memory when most of our players are going to have way more memory than this is going to use, right? Especially in this scenario. It just doesn't matter. It just doesn't matter. And yeah, I think there's a big difference between like hobbyist developers that I've met, and they might have the time, they might have the desire to do this and the ability to, but when you get into that team environment where every single hour of development time matters, you cannot afford to waste it. You cannot afford to do refactors all over the place. That's why I plan a lot before I start a new system. Yeah, I mean, that's exactly it. Or prototyping or anything like that. Much better when you plan and write the code in your head and go through it. Yeah. 100%. 100%.
you're just about to go into the bug fixing phase and like, well, I'm going to refactor a lot of my code and that should handle a lot of the bugs. No, that is a bad idea. First of all, they want to refactor the same code over and over and over, which causes the opposite of spaghettification. You write what I think is you get too clever with it, and I'll talk about that in a minute, but a lot of programmers get way too clever with their code, which really harms them going back to it later.
Refactor and create more bugs. I think too there's just like I've seen some developers, some coders, so like I said, so ingrained in this idea of modularity that they actually just don't write any code. They never make a game. Like, how about just make your game and refactor as you need to? And if at a certain point it will become easier to remake your game from scratch, again, that's what we're doing with our prototype, right? Than it is to continue with all this bullshit. So if you can get through all those unknowns in a prototype and then just rewrite your game from scratch, sometimes there is a point where that is more efficient than either wasting too much time initially planning that you never make anything done, or you just write a whole bunch of spaghetti code that you back yourself into a corner. Isn't the Underdog game just a huge ass if else statement? I know that Balatro is, and I think what's it called? Undertale, I believe is too. And yeah, it works. You might look at the code and say, "Oh, this is the worst code ever." Okay, but Balatro is a released game, and it works, and it made a lot of money. So, is it the wrong way to do things, or is it the right way to do things? As long as it doesn't run under 30 FPS, it's okay. Yeah, I mean, I think there's like a, there are caveats to this idea of just make your game, and you're fine. But I think that there's two sides of the extreme, right? Where you either do things so dirtily that you don't even have a usable game, or you try to do things so perfectly that you don't even have a game. Because you spent 20 years planning what your game system is going to look like, but you never actually just sat down to prototype it.
But anyway, if the basic idea here is if memory and speed and readability isn't an issue, why are you refactoring?
Yes.
Don't do it. Also, bear in mind, a huge con of refactoring is yes, you might be able to get rid of some pernicious bug you couldn't find, but you might introduce a new one.
Yep.
Every time code is rewritten, there's a good chance that bugs will get introduced. And rewriting is writing code. So every time you write code, you may be writing bugs. So think about that. You may have really good code. You may refactor it, and it's a little bit faster, even though it didn't need to be, and now there's a bug in it, which you definitely don't want. The other reason to refactor to make it more readable, you can refactor code thinking you're making it more readable, but you actually make code that's no easier to understand or maintain, or worse, harder to maintain. I've seen programmers look at something and go, "Oh, there's a better way. There's a better way to do this. I shouldn't have used sort. I should have used radix sorting, or I should have used something that they think is incredibly clever and a little obscure." So they refactor their code to use that, and then later on, 6 months later, they come back to it and they have no idea.
Yeah, I mean, I think there are times too where you can sacrifice modularity for optimization, right? And there might be cases where you want that. There are other cases where you want it to be very modular and expandable, and you're knowingly making it not as optimized as it could be in order to accommodate that. So I think that Tim brings up a good point where it's just like, well, what do you want to do with this, and why do you need to do this? When is this used in the game? And if you know that you're only going to use it, like he said, once every 10 minutes, and it's not the most optimized, but every time it happens, the player is in the pause menu anyway. So, oh my god, if there's a bit of a late lag spike when the game is paused, can you refactor a whiteboard without treating people, though? Oh my god, that whiteboard. Fucking Christ. If anybody's curious, there's a previous video from Tim Cain where he mentioned before Jira was a thing, they had a whiteboard in their Fallout office, and to put like the biggest bugs and the biggest features that they needed to work on, and there was no problem. He did that later in a new company, and it was a like HR nightmare. People hated it. It made them feel stressed. And we had a whole talk about how to me there's no difference between a Jira or like especially like a Kanban board with priorities or a sprint board with priorities. There's no difference between this versus a whiteboard. I don't want to get into that again though. I also refactor only when I end up finding some issues, like performance issues. If it happens too often, I will spend time profiling and then fix it. Yeah, I kind of do that too with Colton Chronicles. I think I do spend more time than I should fixing bugs and optimizing in Colton Chronicles. But at the same time, I know that I'm making the experience better. And if it feels more professional, especially when I mention to publishers that I, not a programmer, made this, I'm hoping that they can say, oh, well, if it's this playable and stable, and you're not a programmer, then hopefully they can see that if I do hire these people that are better than me, we can make it even better. Right? I don't want to just shove slop at them and say, "Oh, it'll crash if you do this, crash if you do this, crash if you do this." If you leave those bugs that choose to get too long into development, it can be hard to fix them. That too, yeah. And it can be hard. You might have a bug that prevents you from finding another bug. So it's just like, yeah, it's just like a balance, right? If there's a couple of things clipping into the ground or whatever, some grass clipping into a tree, I don't really give a shit. Who cares? It's a cosmetic bug, as I call it, right? It's a bug that does not impact your ability to play the game, to progress in the game, to enjoy the game. It just, you look at it and you say, oh, that's kind of an weird bug going on, whatever.
Completely forgotten what that kind of sorting was. Or worse, a new programmer looks at it and goes, I've never seen anyone do anything like this. I don't even know where to start. Because you're trying to take your code maybe and add one new feature, but you've made it incredibly rigid by your refactoring. That's a problem.
Yeah.
And then finally, the biggest con with refactoring, and you hear this from producers, is sometimes it will cost you time and therefore money for no immediate benefit. The existing code is bug free. It's not contributing to, in any major way, to the speed, any slowdown in the game.
Yep.
It's not using a lot of memory or whatever. And you have programmers go, well, I want to refactor it for some abstract later benefit. And it's completely fair for a producer to push back on that and going, we have a lot of right now benefits that you could be doing.
Yep.
Why are we doing this for a later abstract benefit we may never need?
Yeah, you should refactor when you need to do it. It's kind of as simple as that. Most games, if you're in professional game dev, do not have the time and the budget to just spend time refactoring code for no reason. We have features, we have milestones, we have things we need to get done. Your time is better spent making these systems better. And if it turns out in the production, the planning of the system that we need to refactor this, then we can schedule the refactoring for it. But otherwise, there's no leeway here. Ideally, yes, we would have all the time in the world to make the best game engine. Everything's modular. Everything can be moddable. It's perfectly playable. We can scale up to infinite number of players. Everybody can play this game. There's no bugs whatsoever. Guess what? There's no game that will ever exist like that because it is never possible. Go ask Star Citizen.
And that is a weird conversation to watch happen between programmers and producers. And it's because of this, and I say this as a programmer. I've said before on this channel that programmers love to feel one way, but try to logic their way out of the explanation. They just want to refactor their code, but they don't have a good reason to refactor their code. But they will argue for hours that they're being logical when they just really want to. And sometimes just wanting to isn't a good reason to. If you can't...
I will defend programmers. And I think that this goes for anybody in game dev, right? It's that we are almost always specialized to do one thing, and a lot of coders are specialized to solve problems and to make their code better. That's what they want to do. So when they don't have anybody or they don't have a good sense to handle themselves, the organization and the meaning behind their work, they might get into this loop of wanting to just do what they know how to do, which is to make code better, to problem solve it, to optimize it, whatever. And that's where the game design, the producers, the creative director kind of contextualize their work and they map it out into you're doing this to accomplish this result. Right? It's like game designers will constantly think of new game ideas if you just leave them to their own devices. And especially like me, a systems designer will think about systems for games that I will never make or have time to make. So I need to contextualize my systems within the foundation of the game that I'm making at the moment, and that prevents me from jumping off of random tangents saying, oh, it would be cool if the game could do this or the game could do this or this. It's like, no, but the game isn't meant to do that. The game is meant to do, here are the pillars, here's the gameplay loop, here's what the game wants to focus on doing and what's trying to be. That's it. That's the circle that I have to work in. People want to keep functions methods under an X number of lines or classes under X number of lines annoy me. They end up making a ton of useless classes that could just perfectly sit in one or two max. Yeah, that too. I mean, I don't think lines of code is necessarily a worry anymore for modern systems. Back when you only could put a certain number of lines of code into the game because Otherwise, you ran out of RAM or disk space. Sure, I get it. But I promise you, you're not going to feel a major difference in a game that is unoptimally calling 1,000 lines of code all the time versus a game that is optimally calling 200,000 lines of code at different times. The optimization is not going to be dependent, and lines of code are so compressible that you're not really going to feel it. Oh my god, the executable is 100 megabytes instead of 2 megabytes. Wow. God forbid. Oh, wait, the texture, the 8K texture that you're loading on the cabbage is more megabytes than that? Oh. Yeah, I guess the number of lines of code didn't really matter that much. You're from a readability and sync. Yeah, I mean, okay, the 200,000, yeah, it's like number of lines doesn't matter as much as how you use those lines. You know, are you calling this function every tick versus are you calling it once every, asynchronously 1 minute, something like that? Are you, pushing it to a different thread? It doesn't matter. It's just, how optimization is more than lines of code. I don't think lines of code matters to optimization as much as when you actually call that code and how you call that code.
If you can't state a good reason, don't refactor your code. So, let me sum up. Refactoring is just a tool. It's a tool.
Yeah.
Like all tools, it can help you a lot if you do it for the right reasons. Like all tools, it can be misused and result in lots of bad things in your game. So, code refactoring. Efficient, do it for efficiency, do it for maintainability, do it for readability, but you don't always have to do it. So I hope that answered your question, B892.
Thank you, Tim, for reinforcing my spaghetti code in my prototype. But I mean, I think that's really where it comes down to, prototype is the perfect time to make spaghetti code and to refactor as needed, because at least in the way that we're developing the game, we know that all of this code is not going to make it to the final game. There might be some of it that I've made that is okay to kind of, translate one for one between blueprints and C++. But in most cases, all I need to do is show how it works, provide the game, provide the prototype, provide the GDD, have a call, run through what I did and what I found not to work, have the more experienced programmer say, okay, well, we can do this, this, and this, and we should do this differently, even though you handled this differently, and then we make it. And likely it might need a little bit of light refactoring later, but for the most part, I've already done the hard work, which was determine what will work in our game. Saw a thumbnail of RDR2 and I got mad now. Yeah, that's a game that's built well. Alright guys, this was great. This was a good video. I'm glad that it wasn't so low level that I couldn't talk about it, because I'm not really a coder. But I do write code, if we want to call blueprints code. So yeah, it's really relevant, and I think it's something that will always be a concern for people in game dev, is how much time do you actually want to spend making the thing that you're making. You watch low level, watch Jonathan Blovids. Yeah, he is very much a low level coder. I think Tim is a low level coder too, but I think Jonathan Blow is one of those guys that he lives in the low level, and I don't think he has to spend time on the high level explaining it to people. Tim is really great at explaining low level concepts at a high level for people that don't know much. He is a very good communicator. I wish I was anywhere near as good as him, but maybe that just comes with experience and time. All right, guys, thank you for watching that one. If you're watching on YouTube, go give Tim a like and subscribe. Of course, the original video link is in the description. And of course, Tim, if you ever see these, thank you for giving me permission to make these. And if you ever want to talk, I'd love to have you on stream or, record a video, and we can just talk game design casually for however long you want. Screw you, YouTube. No, we like YouTube. But thank you guys for watching that, and I will catch you on the next one. Bye-bye, YouTube. Bye-bye.